Not all wind profiles are created equal. The way winds turn with height can completely change how a storm organizes itself. In fact, the shape of the hodograph can give you a preview of what the storm will look like on radar hours before it forms. In this episode, we'll talk about veering and backing wind profiles and how they shape supercell structure. I am Gabriel Harber, and you're listening to the Storm Chaser Coaching Podcast. I'm here with lead coach Trey Greenwood. How you doing today, Trey?
I'm doing well, thanks.
If you folks want to follow along at home or the gym or wherever you happen to be listening to this, don't do it if you're driving, though, by the way. You can wait until you get home to click the link in the description that I'm about to tell you about. We do have a podcast cheat sheet. It's all of the notes we use to organize these episodes. You'll get access if you fill out the form by clicking that link to all of the cheat sheets for every podcast episode we've ever recorded, both in the past and into the future. So definitely would recommend doing that at least one time so you get access to those. All of that out of the way, Trey, let's get to question one. What does veering mean in a wind profile?
Veering winds with height, so as you go up in the atmosphere, means that the winds are turning in a clockwise direction. So let's say you have a southeasterly wind, so wind coming from the southeast toward the northwest at the surface. And then let's say a kilometer or two off the surface, you have winds that are out of the southwest. Those winds are turning in a clockwise direction as you go up in that layer. That is veering. Those are veering winds with height.
Now, what about backing winds? Is that the opposite of veering?
Correct. Backing winds are when the winds turn in a counterclockwise direction with height. So if you had southeasterly winds at the surface and then you switch to easterly winds just above that, they're turning in a counterclockwise direction. That is backing winds.
The Chaser Academy is our premium subscription on Discord, and it is without a doubt the best deal in storm chasing. For less than the cost of a combo meal at McDonald's, you'll unlock instant access to 24/7 text-based Q&A with our expert coaches, weekly group coaching sessions featuring live Q&A, and on-demand replays after each session has completed. Plans start as low as $7.20 per month, so subscribe now and take advantage of the best deal in storm chasing. Link in the description. Then I'm guessing whether you have veering or backing winds, like we discussed with the intro, that can greatly affect how a storm presents itself on radar. So if you could talk a little bit about that, the signs people should be looking for, and then also how looking at the hodograph beforehand can influence exactly what the storm evolution might look like.
The wind profile is really critical in determining things like the storm mode, as in if you're going to see what type of supercells you might be seeing and how those supercells may present themselves on radar. So for a typical, in just a very general sense, when you have veering winds in the low levels of the atmosphere, so again, when those winds are turning from, say, southerly or southeasterly at the surface to more southwesterly just above that to westerly aloft, that's a veering wind profile with height. That is favorable for supercells. The more veering you have and strengthening of the winds as you go up in the low levels, that leads to those larger, more clockwise curved hodographs in the low levels that are generally known to be favorable for tornadic activity. Of course, there are plenty of rules and plenty of exceptions to that rule, but the general idea is that the stronger veering you have in the low levels and strengthening winds with height, that can lead to a greater tornado potential in right-moving supercells. Now, the supercells presentation on radar, that is all due to precipitation venting, and that is very much driven by the wind profile as you go up. So if you have a wind profile that has a little bit of backing in the mid-levels, let's say you have a strong veering wind profile in the low levels, those winds are turning in a clockwise direction from, say, again, southerly at the surface to southwesterly just above that. But maybe they turn back just a hair toward more southerly in the mid-levels of the atmosphere. That can be a favorable situation for those supercells where you have all the precipitation that's thrown away from the updraft of the mesocyclone region of the storm. And that can lead to much better visibility for any tornadoes or storm structure that you might have. We'll talk about the opposite here in just a second. But if you have a little bit of strong veering in the low levels, a little bit of backing in the mid levels, that can lead to a very favorable situation for storm chasing, very visible storms. If you have strong winds aloft as well, very strong winds aloft, really long hodograph in the mid and upper levels, that can lead to also very strong precipitation venting for more visible tornadoes and storm structure.
So people have a good idea visually of what the ideal wind profile looks like, or something close to the ideal. I've heard you say before that meat hook or that scythe shape is what they should be looking for. Is that what you're talking about here?
Exactly right. So that meat hook or sickle shape, so that really curved low-level hodograph and a really lengthy mid and upper level portion of the hodograph, that is usually your textbook case for supercells and tornadic supercells in a lot of cases.
You also mentioned that the opposite of that veering back of the winds in the upper levels, venting the precipitation away, that sometimes you'll have the opposite of that occur. If you could go into that a little bit and what happens sometimes when the precipitation actually starts to wrap around the storm.
If you have a hodograph where you don't have that little bit of mid-level backing to really vent the precipitation away from the storm, but instead the hodograph folds over on itself. It almost looks like a semicircle. So you have strong veering and strengthening of the winds in the low levels, that clockwise sickle shape in the low levels, but that kind of keeps going into the mid and upper level. So it folds back over on itself like a semicircle. That is not as good for efficient precipitation venting away from the mesocyclone region of the storm. That is going to throw a lot of precipitation right out in front of your storm, your tornadic region or mesocyclone region of the storm, and that can make visibility and chasing those kinds of supercells very difficult. This is something in the southeast a lot. It's one of the reasons why the supercells in the southeast tend to be very high precipitation in nature. Of course, there are other factors at play, but that is one reason you often see those hodographs out there that are that semicircle shape that kind of fold over on themselves. And that really tends to throw a lot of precipitation out in front of tornadoes and makes them very difficult and can really wrap them in precipitation a lot of times, making chasing very difficult.
Yeah, and you'll definitely want to have a plan ahead of time. A good way to make sure you do is by joining our Discord community. Link for that in the description. You can talk with our other members as well as our coaches about what these hodograph shapes mean for your upcoming chase. And Trey, if you would like to go into that as our final question here a little bit, what should people be taking as precautions depending on the shape of the hodograph? And what sort of things can they do to either make sure they have an advantageous position for viewing and also for keeping themselves safe?
So if you see that hodograph that folds over on itself like a semicircle, that is going to be your more dangerous situation. Those supercells can tend to be much more high precipitation in nature. So you really may not get a good look at tornadoes in those situations. You may have to be right in the inflow notch or the bear's cage, which in those types of situations is extremely dangerous. The types of wind profiles where you have that little bit of backing in the mid levels, those are much more favorable. And especially with strong winds aloft, those are much more favorable for the more visible tornadoes and storm structure. So you can more easily position yourself ahead of those features. With those kinds of supercells, those semicircle hodographs, that's not the case. Very high precipitation nature to those storms. So you want to give yourself a lot more space in those situations. And you really don't want to chance it. We talk a lot about how high precipitation storms are the most dangerous. They're the most dangerous for a reason because the features are hidden. And so when you have those semicircle hodographs, that is a sign that you really need to give the storm a little bit more space and respect.
Remember to check out those links in the description below and then watch another video.